Puja, the sun does not, or dictionary, you disappear. Western hemisphere, international sphere. It will help you certain the affairs, the signing over which particular apparent position. If the sun is present somewhere here, if the sun is present somewhere here, we can say that the northern hemisphere will have greater exposure to sunlight, isn't it? So it will be summer in the northern hemisphere. And simultaneously, if you take the position of the earth, let's say here, with the tilt like this, and here if you draw the equator, you can always say that in the second position, it is the southern hemisphere which will get greater exposure to the sun, and northern hemisphere will get lesser exposure to the sun. So whichever area gets a greater exposure to the sun rays, they will always end up experiencing a distinct summer season. Okay. Lakshya, yes, you can go for the note making based upon the class. How do you, if I take you back here, let's suppose. Now, in this case, if I have to get an idea about which latitude are we talking about here, so how do you calculate that? So you will always calculate that with reference to equator. Equator is the largest latitude, and that is referred to as the reference point. That is referred to as the reference latitude with 0 degree. So this is your 0 degree. So how do you do that? You measure the angle. And how will you measure the angle of this latitude on the surface with equator? It is not possible. So that is why you draw an imaginary line joining the center, and that is joined by another imaginary line. And this angle which is calculated, let's suppose this is 40 degree as we had discussed yesterday. So this will be 40 degree, and because it is to the north, it will be 40 degree north. So that is how you calculate the angle of the latitude. In case of longitude, the same point is done, or the same methodology is followed. The difference is there you consider prime meridian as the reference point. Okay. Fatima, why Antarctica feels constant day in winter? Because when we talk about the winter season in northern India, at that point of time, it is summer season in, or when we say winter season in the entirety of India, at that point of time, it is the summer season in the southern hemisphere. And why is it summer season in the southern hemisphere? Because southern hemisphere appears to be tilted towards the sun. And in that position, the solar rays will always be reaching the region of Antarctica. That is why the polar areas, they experience 4 to 5 months of continued daytime, and again followed by 4 to 5 months of continued nighttime. And does sun's distance also affects the earth's seasons? No, it does not. Okay. Familiar asteroid belt is basically a group of asteroids or planetesimals which move between the Mars and the Jupiter, and they have been present there ever since the time of the formation of the various different planets itself. So these are those pieces which have not materialized into any kind of planet. Just imagine that at one point of time, close to around 4 to 4.5 billion to 5 billion years ago, the entire solar system that you visualize now, that was covered with such kind of materials. Now that is restricted only in a certain section. That is why there is such a greater interest amongst everybody in order to be able to explore the asteroid belt, so that they can get an idea about what the early solar system would have looked like. Okay. Manas, is it necessary to remember all the time of the country according to GMT? Absolutely not. Basu, any of them you can cover. Okay. Right. And then what happens in the rest of the 2 months to the polar regions regarding the seasons? They get some adequate amount of sunshine, and they do not experience a complete day or a complete night time. Circle of illumination, Avni, is that imaginary circle which separates the day and the night time. That is it. That is an imaginary circle. Because think about it, if let's say sun is here, and here is where the planet is rotating, the entire planet cannot be lighted up by the sun. Only the half of the planet which is exposed to the sun will be lighted by that. So that imaginary line separating the lighted portion and the darker portion of the planet, that is circle of illumination. Okay. We have to read GC Leong book. Yesterday also I have mentioned that not very much required. If you are thorough enough with the class and the NCRTs, more than sufficient. During autumn in one hemisphere, which season is experienced in the other hemisphere? It is spring. Okay. Chandrasekhar, I'm not understanding why Earth is not falling on the sun. It is a fall here. It aided all and they should get in the now you get questions sometimes about rock types, plate tectonics, okay, and associated phenomena. Okay. So these are the ones which are relevant for your prelims examination. When we talk about the mains examination, this is where this particular unit is very, very important, because every other year you do get a question from mains or from this area in the mains examination. And UPSC doesn't hesitate to repeat the questions from this particular area. Very frequently, you will find UPSC to be asking the same questions again and again. Now, here, if you talk about this particular area, you get questions about continental drift theory, continental drift theory. You do get questions from seafloor spreading. Then you do get questions from the portion of plate tectonics. In fact, in 2022, UPSC had also asked a question about the rocks. So, basics of rocks. Okay. So these are the areas frequented by UPSC, and we'll also take a look at the type of questions which have been asked from this area. We'll be discussing the mains type of question, and with that, we shall also be approaching the portion of how to write and create answers for geography. Because once you understand the art of writing good answers for geography, that is going to help you in other subjects as well. Because here you get an idea about how to depict the answer in a visually or a pictorial manner which is visually appealing for the evaluator as well, and you are able to attract the attention of the evaluator for a longer span of time, and eventually that is your goal in any of the paper that you are writing for the mains exam. So that is what we are going to look at. So in this particular chapter, what is it that we are going to study? Ideally, if you open up any reference book, if you open up the basic books, etc., which are available in the market, you will generally find that straight away one attacks the interior of the earth, the structure of the earth, the layers which are present in the earth. And then after that, you proceed ahead. But here, what we shall be doing is we shall be trying to understand the formation of planet Earth itself. How is it that planet Earth got created? Now, this is not to say that a direct question will be asked from this particular area that describe about or discuss about the formation of planet Earth. But once you are able to decipher that, once you are able to imagine the basic formation in itself, that will enable you significantly to also understand that why is it that when we say the core of the planet Earth, core is consisting of iron and nickel. Why is it that core is only consisting of iron and nickel? Why is it that inner core is in solid state, outer core is in liquid state, different portions of the core have different particular states? So why is that the case? Although, how is it that water appeared on the planet Earth? All those things and topics become much easier to understand once you are able to fathom or imagine how the formation of the planet in itself took place. After that, once we have understood that, once we have understood the layers, then we will go ahead with the portion of the different types of rocks, how the different rocks are created. When we talk about an igneous rock, what are the different types of igneous rock? When we talk about a sedimentary rock, why is it? And we will also be touching upon areas, for example, most of the modern or rather the medieval architectural buildings that you find, They are made up of red sandstone, that is a sedimentary rock. Why is it so? Why not igneous rock? And what is metamorphic rock? What is rock cycle? Those phenomena we will be looking at. And then we will be taking a look at the origin of continents and oceans, whereby we shall be analyzing the various different theories provided by the geographers, the scientists in detail. We shall be talking about the continental drift theory. What is it that Alfred Wagner wanted to postulate? Then we will be talking about the seafloor spreading, convection current theory. Eventually, how all these theories they helped us postulate the plate tectonic theory, which is the relevant one. That is something we are going to emphasize. And in this journey, we shall also be touching upon the formation of the Himalayas themselves. That when we talk about the Himalayas being the mightiest mountain across the planet, how is it that they have been created? After all, in the Himalayan mountain ranges, you find evidences of sea or oceanic deposits. So that means the mountains that you see now, some of those would have had been underwater. So, what happened actually that the Himalayas got formed and got created, and why is it so that even today the height of Himalayas is still increasing? So, all those factors we shall be looking into and we shall be emphasizing upon. After this particular unit and chapter, let me assure you, your understanding of the geographical concepts which are going on around us, be it earthquakes, volcanoes, they will be much more clearer, even though earthquakes and volcanoes as a separate unit we will be handling after this as well. Okay, so we start with the very basic, that is the formation of planet Earth. Okay, Gauri, what is your question, my dear friend? Please, everybody, I would like to appeal to everybody, request to everybody. See, if I start taking all the questions immediately, I don't think we will proceed significantly in terms of coverage of syllabus. So, in chunks, I shall be taking up certain questions. In the meanwhile, kindly have patience. Your question will be looked into and will be replied by the SMEs, or I will take it up at the end of the session or in the in between as well. All that I ask out of you is have a bit of patience in between. Don't get very restless. Okay. So, why is ideal necessary? That is, why is international dateline necessary? In order to demarcate that when is it or from where is it that new day will be followed. Yesterday we looked into it that in the same area, that is Alaska and Japan, you had night time, but in one area you had 25th of July, in one area you had 24th of July. So ideal demarcates the difference between one day to the next, just like prime meridian demarcates the time difference and a reference for time. So exactly opposite to the prime meridian, you have a 12-hour gap from both sides. So that ends up demarcating the new day. Okay, I hope that is understood. Anti-meridian is the exact opposite of the prime meridian. Okay, now we continue with the portion of the formation of the earth. Now, as of now, I want you to understand clearly that what this formation is about, how this formation has actually taken place. Okay, so first of all, we'll be touching upon the very basics here. What did exist around 4.5 to 5 billion years ago? What actually did exist? So, when we talk about 4.5 to 5 billion years back, our solar system was nowhere close to what you see today. Today, when you take a look at the solar system, and I'm sure since your childhood days, from the school projects to the simple drawings, you would have all drawn those planets in the answer copies and in your notebooks as well, where the planets would be revolving around the sun. And that is the idea of solar system which has stuck in our minds. But understand that it was not the case around 4.5 billion years ago. So, what was present if the planets were not in existence? What was present around 4.5 billion years ago? So, here, when we talk about it, at that point of time, when the sun was newly created and the sun was born, at that point of time, here, let's suppose We demarcate this as a sun. Now, all around the sun, you had a lot of various different dust particles, simple, smaller dust particles, which were aided by the gravitational pull of the sun. Many of them, they fell directly into the sun as well. Because you have to understand, and you will study in greater detail about it when you study the portion of science and tech, that sun also undergoes nuclear fusion reaction. And when we say a nuclear fusion reaction, that is where smaller atoms and smaller molecules, they end up combining to produce very high amount of energy in the process. And not only do they produce high amount of energy, they also subsume the other particles nearby. They attract the other particles nearby. So many of these dust particles, they actually were consumed and subsumed by the sun itself. But large quantums of it, and when I say these dust particles, they were of various different sizes. You don't have any particular size which could define that all the dust particles were of this size. Now imagine a scenario where these dust particles, they were consistently moving around the sun. Consistently. Now, when you have so many millions, billions, and trillions of dust particles moving against or moving in the same place, what can happen? Collision can happen. These dust particles can end up colliding with each other. Isn't it? That is absolutely possible. Now, here also, you have to understand something. Collision can be of various different types. Obviously, you study that in physics about the different types of collision, but let's assume we have not studied about the types of collision. But just to give you an idea, if suppose you have two objects, let's suppose I have two objects. Now, if these two objects, they collide, right, from opposite sides, and they collide with a significant velocity, what will happen? They will break down, they will get disintegrated, and they will get separated as well. But nonetheless, they will be producing some amount of heat, some amount of energy. Every collision will produce some amount of energy. But there can also be a collision where a particle is moving, let's say, at 5 kilometers per hour, the other particle is moving at 500 kilometers per hour, and it simply comes and collides. Now, in this case, what will happen? There will be heat produced. And due to the heat produced, these materials, they will, at the point of contact, there will be enough heat produced that these materials will end up joining with one another. Isn't it? So that kind of collision is something which started producing larger materials. So these dust particles, they would frequently collide. But then few of those collisions would lead into a situation where the particles would actually stick together. Why? Because with every collision, very large amount of heat would be produced. And when you would have a very large amount of heat produced, as a consequence of that, what would happen? The materials would get welded together. So the mass of these dust particles would increase, isn't it? So basically, let us summarize that. Let's use this particular slide. So first of all, you had dust particles. Okay. Now these dust particles eventually would undergo collision. Now, whenever this collision would happen, that would produce heat. Due to the heat produced, the materials would start sticking together, because anything which is hot, materials tend to stick to that because it gets molten in molten form. So, size of the particles would increase. Would increase. Now, as the size of the particles would increase, what would be the consequence of that? Now, yesterday also we talked about it when we were talking about gravitation. Any object which has got mass, that can subtend a kind of a gravitational pull of attraction. So larger the mass, greater the gravitational pull of attraction, right? So let me write it down here. Any object with mass extends a gravitational pull of attraction. Gravitational pull. Larger the mass, greater the gravitational pull. Okay, that is why Sun, having the largest mass in the solar system, has the most significant amount of gravitational pull which is extended. So, like that, as the size of the particles would increase, can we also not say that the gravitational pull of attraction of these particles would also increase? Increased gravitational pull. Okay. Now, when you have increased gravitational pull, a larger object, imagine, is moving by, and you have smaller dust particles. Now, in increased gravitational pull, wouldn't it mean that these particles, they would get attracted? So, increased gravitational pull means more particles would be attracted. More particles would be attracted means greater number of collisions, isn't it? So, more particles would be attracted. Okay. And when more particles would be attracted, increased collisions. Now, with increased collisions, what would happen? Again, they would produce heat, and this cycle would continue. This cycle would continue in various places across the solar system. And that is how slowly and steadily these trillions and trillions of these dust particles, they were consumed by these collisions. With every collision, enough heat would be produced. Now, after this process would continue for many millions of years, what would happen was that rather than the small dust particles, you had large chunks of mass which would be created. The size that you observe in the case of very large asteroids, that size. So, such very large masses would be created rather than those dust particles. And those were referred to as the building blocks of the planets themselves. So that is what is also referred to as a planetesimal. So eventually, increased collisions led to creation of planetesimals. What are planetesimals? Large chunks of matter, building blocks of planets. Okay, so these planetesimals, they started moving around. So earlier, what you had a scenario of only the dust particles moving around. Now that quickly changed, and you rather had the large planetesimals, because these dust particles, they underwent large number of collisions, produced enough heat to be sticking together and create those planetesimals. Now, just like the earlier process, these planetesimals would also collide. Now, when the planetesimals would collide, now Imagine the amount of heat and energy which would be produced. Obviously, the energy would be very high. The amount of heat produced would be very high. So imagine if you have a condition where two large planetesimals would collide. Now, at this point of contact, heat produced would be so very significant that the materials here would not only get liquefied, in certain cases, they would also get vaporized. And then these two particles or these two planetesimals, they would ensure or they would make up a larger chunk. So these planetesimals, they also underwent collisions. Underwent collisions. Now, slowly and steadily, the size kept on increasing. Eventually, they collided and large amount of materials they came together to form what was referred to as the earliest form of the planet, what is also sometimes referred to in technical terminology as the protoplanets. So those were the earliest form. So here, in case of the planet Earth, what was created was a large molten mass. Large molten mass. Right? Early Earth. Around 4.5 billion years ago. Now, here, initially when the planet was created, everything was in molten form. Everything was in a molten state. Molten means something which is liquid, right? Solid, when you heat solid, it becomes liquid, isn't it? So that is the molten form of mass which was created. Now, in fact, roughly around 4 billion years back to 4.2 billion years back, it is at that point itself when moon was also created. We'll come to that. But before that, let us analyze this stage a bit deeper. When we talk about any molten ball of mass or the planet having a molten state, that in itself tells us about the formation of the structure. Now, for this, what I want you to do is, I want you, for reference purposes, to imagine a kind of a tumbler, a glass tumbler or a glass cylinder. Now, in this glass cylinder, let's suppose you put in some amount of water, some amount of honey, and some amount of, let's suppose, oil. All three are liquids, right? Water, honey, and let's suppose you provide some oil. Now, do you think they all will be mixed together, live, and will exist in a homogeneous state? Or do you think there will be a difference in terms of where they are placed? Very good, lighter will rise up. So, in this case, which one do you think will rise up? Oil will rise up, followed by water, then followed by honey. Honey will be the densest one, it will settle to the bottom, isn't it? That is something which we have understood. Now, apply the same logic to the molten form of Earth, the liquid version of Earth. Now, when the Earth was in liquefied form, it did exist like that for many millions of years. Now, in that state, what will happen? The heaviest materials, the heaviest liquids, won't they all settle down? Won't they all start to sink? So, all the heaviest materials, they started sinking to the bottom. Now, before I proceed ahead, I want to check a normal kind of an aptitude question where many of the students bungle up in terms of the planet Earth, because that is how we have perceived planet Earth always. If I tell you, if I ask you that if this is the planet Earth, what will you consider as the bottom of planet Earth? Will this be considered as the bottom A, or will B be considered as the bottom of the planet? What do you think? Thank you, guys. So, other than a couple of you, I think all of us agree that center will be the bottom. Okay, from all areas, if you go to the bottom, you will reach somewhere at B. Okay, now here, after this, when I talk about, let's say, the molten materials. Now, the molten materials, the heaviest amongst them, they started settling to the bottom. And by bottom here, we mean the center. So, all the heaviest elements at that point of time, not today, at that point of time, the heaviest elements which were present, those heaviest elements, they settle down at the bottom, around the center. Okay. Heaviest elements settled at the bottom or at the center. Now, here, which were the heaviest elements available on the planet at that point of time, if you think about it? So, at that point of time, the heaviest elements, so at that point of time, you did not have enough uranium, you did not have those heavier elements. The heaviest elements which were present were actually iron and nickel. So, iron and nickel being the heaviest ones, so they started settling down. And they started concentrating themselves around the bottom. Now, till today, the core of the planet Earth is actually dominated by iron and nickel. It is the presence of iron and nickel in the molten state in the core that ends up providing that magnetic field of attraction for the planet Earth as well. We'll come to it. What is geomagnetism? We'll come to it. But iron and nickel settle down at this point of time. So, till now, what we have seen, before proceeding further, let us have a quick recap. Till now, what is it that we have understood? So, in the earliest form of the solar system, you had the sun surrounded by millions, billions, and trillions of particles underwent collision. Why? Because they were moving around the sun and they would collide because each of them would lie in each other's path. Now, each of these collisions would produce heat. And due to that heat, the materials they would start. Why would they produce heat? Any two objects, when they collide with a significant velocity, they produce heat always. So, due to that heat, there would be a kind of a natural welding of these materials. And these materials would start to grow larger in size. So, these dust particles, after a combination of many of these collisions, they would grow in size. And after a combination of such millions and billions of collisions, they would get converted into planetesimals, the smaller chunks. And eventually, these planetesimals would combine through collisions, obviously, and heat, obviously, and that would form the earliest form of the planets. Now, planet Earth was in a molten state. Heaviest materials, that is iron and nickel, they settled at the bottom. Till today, they form the core. So, I hope till this point it is clear. Now, here, you have to understand that as the heaviest elements settle down, now this is a planet that we are talking about. This is not a small sphere that we are talking about. What is the radius of the planet? Roughly around 6370 kilometers or 6400 kilometers on an approximate value. You can think about it. So it is a large area. So in that case, many of the materials were still sorting themselves. The lighter materials were trying to come up, heavier materials were trying to sink down. But then the solar system was not as stable as it is today. You still had a lot of these small planetesimals which would move around in each other's orbit. It is at that point of time, roughly around 4.2 to 4.3 billion years ago, when the planet had just been created, when a very large mass of the size equivalent to Mars, the present day Mars that you see, that sized object, actually, it was not Mars in itself, but other object with the size of Mars, the mass almost equivalent to Mars, it is said to have collided with the planet Earth. So imagine that scenario. So here you had the molten planet Earth. You had the molten planet Earth, which was still forming, which was still settling down. And simultaneously, at that point of time, it was hit by a very large object. Now it is in liquid form. Planet Earth has still not solidified, it is in liquid form. So, in that liquid form, if a large object collides, what do you think will be the resultant of it? Can I say that the molten materials, they will be splashed away? Because if the force is humongous, that will create a large enough splash, and a lot of these materials would actually be splashed away. Can we say that? Yes? Good. So here, large material, actually, it collided, and large portions of that liquid, they were splashed away. They were removed from the planet. Now, when these materials were removed from the planet, let us assume that you represent a kind of a large chunk here of material which was removed. Okay, let's assume. Now, this large chunk of material which has been separated, will that be impacted by the Earth's gravitational pull, or will that escape Earth's gravitational pull easily? What do you think? Will the Earth's gravitational pull be able to attract that, or will that escape the Earth? It will be attracted. Good. So, this was attracted by the planet Earth. This was held by the gravitational pull of the planet Earth. And that is when this large chunk, it actually started rotating across the planet, aided by the gravitational pull of the planet Earth. Now, obviously, it was rotating at the same time revolving as well. So, any kind of that circular motion, it automatically creates a spherical shape. Anything, any object, if it continues to rotate in a circular motion endlessly with a great velocity, and when it is ready to change its shape, it will turn into a sphere. So, it changed into a spherical shape, a small spherical shape. And what is it that this spherical shape is known as today? Can you take a guess? Very good. It is moon. So this is how we had the creation and the formation of moon as well. So this is how you had the formation of the moon, which is the satellite of the planet, considered to be the satellite of the planet. Now, that moon would not have been created had there not been a large collision by that object. So that object, which we can only estimate and postulate about it now. Now we don't have a direct evidence of that larger object colliding with planet Earth. So that was named as Theia. Mars-sized object collided with planet, liquid Earth, separated a chunk of mass This mass was held by the Earth's gravitational pull. By Earth's gravitational pull. And this led to the formation of moon. So this was your large object, Theia, which collided. And that is how formation of moon happened. That is why when you read the various different theories about the formation of the moon, this is what is referred to as the giant impact hypothesis about the formation of the moon. This is as per the giant impact hypothesis. Because obviously there was a very large impact. Such large amount of impact Earth has never experienced ever since that point of time. It was, in fact, one of the largest collisions that Earth witnessed, and that too it witnessed in its very unstable form. Had that been present, or had that collision taken place when the Earth would have been solidified, then the impact of it would have been disastrous. The climate, the atmosphere, everything would have been completely taken away. So that is why it is referred to as the giant impact hypothesis. So till now, what is it that we have seen? We have seen that how dust particles, they actually collided to form the planetesimals. And slowly and steadily, as the dust particles collided, their size increased. With the increase in size, that meant their mass would also increase. With the increase in mass, that would mean the gravitational pull of attraction would increase. So more particles would be attracted, more collisions would take place, size continued to increase, and with each and every collision, heat would be produced. Because with every collision, heat is produced. And that heat eventually led to the molten form of planet Earth, whereby the heaviest elements, that is nickel and iron, would settle at the center. After that point of time, when the materials were still rearranging themselves, a larger mass from the solar system, size of Mars, that is Theia. Theia was a celestial object which collided with the planet, splashed around a lot of materials which were held by the planet's gravitational pull, and it continues to rotate around the planet till today, and that is what we refer to as the moon. Now, after this, we come to the stage where the cooling down process initiated. So we have till now come to the stage where still everything is in a molten state. Okay, it is still in the molten state. Now the cooling down process initiated. Now here again, I want you to apply your logic here. When I say that the cooling down process was initiated, where do you think the cooling down process would have actually been initiated? Would it have started from the surface, or would it have started from the interior itself? Where do you think? From the outside or from the inside? Correct. From the surface. It is the surface which started to cool down. Obviously, by this point of time, the lighter materials, which were the lighter materials? Silicates, alumina, right? But by silica, we don't mean silicon. Silica is an oxide of silicon. Okay, so silicates, alumina, all of these, they started coming to the top and they started solidifying. So the outer layer, thin outer layer consisting of lighter materials like silica started to solidify. Now, here is an important concept that you have to understand if you have to understand about the presence of water on the planet. That how is it that water came into existence? Now, for this, I want you to relate it to your very normal everyday experience of, let's say, if you have seen someone boil a utensil of milk, or let's say heat any liquid material. Now, let's take the example of milk. I'm sure you would have observed this if you have not done it yourself. It is high time in your life that you are aware that when you actually boil milk, and after you close the stove down or after you shut down the flame, After a few minutes, you will observe a thin crustal formation on the top of the milk. Right? Slight solidification happens. If you touch it, the outer surface, it appears cooler. But if you dip your fingers, what is the temperature? Temperature is very high. Your fingers can burn off. That is how hot it is. So, what does that mean? That while the outer surface is very cooler comparatively, the inner surface is still very hot, isn't it? Now, as the outer surface solidified, the inner surface was pretty much in a liquid state. Now, here, the inner materials, when I say they were in a liquid state, you also had gases which were trapped. Now, here you might have a question that till now we were considering solid and liquid. Where did gas come into the picture? So, understand this. When you talk about any compound, let's suppose, or when you talk about rather any element, let's suppose silicon. Now, if you heat silicon, it will get converted into liquid state, isn't it? If you heat, let's suppose, iron, it will get converted into liquid state. But what if I have silica? Silica is solid. Iron oxide, this is also solid. What happens if I heat this up? Now, the silica, or rather, when I heat up the silica portion, silicon will get converted into liquid. But what about oxygen? Oxygen will get converted into gas, isn't it? So when I heat this up, what do I get? Molten silicon and iron and gaseous oxygen, isn't it? So in the interior, you had so many different elements that various different gases also were bubbling amongst the molten portion. Now, gases are light. Now, these gases, when they are light, they will have a tendency to rise up to the surface always. So, from all the areas, the gases, they began to rise up closer to the surface. Okay, the gases which were trapped, these gases which were trapped inside. Now, the solid outer surface, it was not as hard as you have the surface today. Today, the surface is much more harder because it has cooled down, obviously. At that point of time, it was just cooling down. So, the surface was still weaker. So, these gaseous materials, these were trapped gases. Trapped gases rise to the surface. Now, when they rose to the surface, with the pressure, they would bring molten materials as well. And because the surface, outer surface was not very hard, they could easily be able to break through the surface. And that is how eventually you had volcanic eruptions. Hundreds, thousands, millions, billions, and trillions of volcanic eruptions. They rocked the entire planet because the surface was so very weak. At each and every place, these gases would start to come up. So that is how these gases, they escaped through the various different volcanic eruptions. Every day there would be hundreds and thousands of these volcanic eruptions. So this is what is also referred to as, in the phase of evolution of the planet Earth, this is referred to as the phase of degasification. Now, when we say the phase of degasification, that is basically that phase where a lot of molten materials, along with the gases, they would simply exit the interior of the planet. That would bring about huge amount of volcanic eruptions. Now, amongst the gases which were released, you also had oxygen and hydrogen which were released. Now, oxygen and hydrogen at that temperature, they would combine to form water vapor, right? So, amongst the gases to be released, amongst the gases, you had various gases like ammonia, methane, carbon dioxide. All of these were also released, right? So, amongst the gases, oxygen and hydrogen were released. They combined to form water vapor. Now, after being released, they would rise up, and that water vapor eventually would form the clouds. So, a situation came where the entirety of the planet was surrounded by a very dense and thick layer of clouds all around. Very dense and very, very thick layer of clouds that surrounded the entirety of the planet. And these clouds were created how? By the endless amount of volcanic eruptions which would continue to happen. Dense clouds. Now, at this stage, when you had dense clouds, very thick clouds which were present, they would block the sunlight. And when the sunlight would be blocked, there would be cooling. So the surface that started to cool down very significantly at a very swift pace. And in the meanwhile, lot of heat from the interior had also been released in the form of these volcanic eruptions. So a lot of that heat would be continuously lost. So the planet began to cool down. And as the cooling down happened, more volcanic eruptions, more clouds, and the density of the clouds increased. Now, these clouds were rich in water vapor. So, what would they bring? They brought about continuous rainfall. Not the rainfall that we experience today. That is referred to as the phase of torrential rainfall, which the planet experienced. In fact, as per our estimates, today we can estimate that based upon the various different rocks that we study, the planet experienced continuous rainfall for close to around 7,000 to 10,000 years. Imagine, in the present condition, even if it rains for 3 days continuously or 4 days continuously, the entire city is flooded. Imagine a situation where the entire planet received rainfall continuously for 7,000 to 10,000 years. And it was a continuous downpour that further cooled down the planet. And when the planet started to cool down, the outer surface, it started closing in. The outer surface, it started developing certain wrinkles of sort, right? Certain areas, they got deflated, certain areas, they gained a height. So that continued, and that was a process. But at the end of this, the end of the entire process, all of this actually led to the formation of oceans and seas and the entire hydrosphere that we encounter today. So this dense clouds led to phase of torrential rains, which is said to have been continued for 7,000 to 10,000 years and led to the existence and creation of your oceans and seas. It is at this point of time, around 3.5 billion years or 3 to 3.5 billion years back, when life got created on the planet. And the earliest form of life was a very simple form. It developed underwater. It was, in fact, as again we have estimated that obviously at that point of time nobody had a CCTV camera to witness the evolution of life, so we can only estimate based upon the existence of various different evidences. So you had a kind of a cyanobacterium or blue green bacterium which developed underwater, and it was the one which would utilize the carbon dioxide present around it, would produce oxygen. That is how the blue planet that we refer to today, That is how the entire existence was created. So, eventually, it is not as if the volcanic eruptions stopped. The volcanic eruptions continued. Different types of eruptions would happen. Various areas they would emerge above water, over water, and various smaller portions of landmass that started getting created. Now, these smaller chunks of landmass, over a time period of hundreds, thousands, millions, and billions of years, they would collide with each other and they would actually get welded together. And that is how larger lands would create. And that is how eventually the continent sized lands that started appearing on the planet Earth. Now, significant change happened when you had the development or the growth of trees somewhere around 600, 700 million years back. And when the trees they started developing, obviously they would develop significantly because carbon dioxide was very predominant in the atmosphere. Oxygen was still not present. Oxygen was produced by these trees in large amounts and large chunks. And that is how slowly and steadily, over the past 400 to 500 million years, the concentration of carbon dioxide in the atmosphere has been coming down, whereas the concentration of oxygen on the planet has been ever increasing. And that is why nowadays, in the case of speciation, or rather, in general, majority of the species that you will observe which have been created now or in later period, they are oxygen based species that they require oxygen for survival. Okay, so that is about the formation of the planet. Okay, I hope that is understood. Formation of majority of the planets is the same. It is the distance from the sun which ends up influencing the surface and ends up influencing the atmosphere of that region as well. Okay, nitrogen was created during the phase of degasification when ammonia was released, right? So I hope this entire process of formation is clearly understood. This is not something that you find in your books easily. This is also referred to as the accretion theory of the formation of planet, and that is something which will help you understand the present day context as we move ahead about the interior structure of the planet and the layers of the planet. You will get a better idea with that. So UPSC has not directly asked a question for GS that tell us about the formation of the planet Earth itself, but the various different implied questions that UPSC keeps on asking. So there, the formation is something which will be helpful. Okay. So I hope that is understood. Phase of torrential rainfall. This is the phase of torrential rain. When you had a lot of these dense clouds, they brought about heavy rainfall. Okay. Now, after this, we further develop this concept. So, here you have the planet which has cooled down. And we have already discussed that the cooling down is a process that would happen from the outside to the inside, isn't it? So the cooling down started happening, and the outer surface cooled down and became very hard. Cooled down and became very hard. Can we say that moon is a part of Earth? Absolutely yes. Moon was once a part of the Earth. So the outer ones they cooled down and became very, very hard, very, very stiff, very brittle as well. But the lower portions did not cool down significantly. Lower portions or the portions in the inside, they were still very hot. That heat continues to be trapped till today. This is the reason why the region of the core, it is in liquid state. Outer core is in liquid state. Why? Because of very high temperature. So, while the outer portion started cooling down, the inner portion of the planet still retained that heat, just like the milk example that I gave you. Till today, various events that you observe, that is, be it volcanic eruptions, be it the movement of the land masses creating various different landforms such as the Himalayas themselves, the earthquakes which ravage various different areas, cause complete destruction, devastation. In certain areas, the land gets and sinks. All those events on the land, they are directly or indirectly driven by that heat which has been retained in the interior of the planet. And that is what is referred to as residual heat. Residual heat. Heat retained in the interior since the time of formation. Okay, so this residual heat is still considered to be a key source of all the various forces that the planet experiences, which comes from the inside, what we will study as endogenic forces eventually. So all those forces are driven by this residual heat. Now, while the outer surface of it is very hard, very brittle, can break easily, as you start going into the depth, that is in the region of the mantle, beyond a certain depth, materials are still solid, but they are very dense in a compressed state. So you can imagine that rather than the materials breaking due to immense pressure, they would deform easily. That is how, as you start going into the center of the planet, that is how the materials, their density, their properties, their behavior, everything starts to change. Okay, so that is about the structuring. Now let us come across the portion of the interior. What is the interior composed of? But before talking about what is the interior composed of, I'm sure many of you would have this question in your mind, that how do we know about the interior? Whether the inner core is in solid or liquid state, nobody has gone there. How do we know about it? What do we know, or how do we know what is the condition that mantle is in? This person is telling us that the mantle is so very dense that materials can get compressed and deformed rather than breaking. How do we know that? So we have various sources of information when it comes to the idea about interior of the earth. Sources of information. Now these sources of information can be classified into, very good, direct sources as well as indirect sources. So what are our direct sources? Direct sources of information which give us an idea about what is included or what is contained in the interior. And when I say direct sources, means what? That first hand information is given. By that, we get the first hand idea about what is contained, right? So here, the direct sources are two. One is studying the volcanic eruption, volcanic eruptions, and secondly, by digging and mining. Obviously, here also we have a significant bit of limitation. You cannot end up digging a hole endlessly. There's a limitation to that as well. Because when we talk about the digging and the mining, the deepest hole which has been dug is where? It is in the Kola Peninsula. I hope we are aware where the Kola Peninsula is. So, Kola Peninsula is to the northern part of the Eurasian continent. If you look into there, you have a Kola Peninsula. Okay, I will show you in the map as well. But even if I don't show you in the map, I want each one of you to open up the atlas after the session and locate and understand where the Kola Peninsula region is. But nonetheless, that is where the deepest hole was dug. And the hole which was dug was roughly around 12 kilometers deep. It is a different matter altogether that China right now is digging multiple such 10-kilometer deep holes to understand more about the interior of the planet Earth. But that Kola Peninsula hole was dug by Soviet Russia at that point of time in order to have a better understanding about the interior and also for various other purposes. But that hole was abandoned because beyond a certain depth, the the temperature would be so high that people would eventually die as well. Many people have lost their lives. So that is a limited source of information that we get. But nonetheless, at those depths, we get an idea about how the temperature tends to increase. And we do know that as we go into the depth of the planet, the temperature would increase. And why is that? That is because of residual heat, which has been trapped ever since the formation. So this increase in temperature with depth, that is what is also referred to as the geothermal gradient. Geothermal gradient. Increase in temperature with an increase in depth. Okay. Now here we have to understand that these volcanic eruptions also, we'll study about volcanic eruptions as well in greater detail, that where the materials come from. The volcanic materials, they don't come from the core. They come from the region of the mantle itself, upper portion of mantle in most of the cases, in few of the cases from the lower portion of the mantle. So there also you have limited in source of information. So then we rely on the indirect sources of information. What are the indirect sources? So first is by study of earthquakes. Study of earthquakes. Now, the earthquakes, whenever they happen, they end up generating energy waves which are referred to as the seismic waves. So, by study of the seismic waves, we get an idea about the interior. Then, other than that, we get an idea about the interior by studying the magnetic field. Magnetic field of the planet. Understanding any variations which exist in the magnetic field, any interruptions which arise in the magnetic field. By that, we get an idea whether the internal structure on the or the interior structure is changing at all or not. Then you have the study of the gravitational force. Gravitational pull at various different places of the planet. That also gives you an idea about the curvature, about the shape of the planet in detail. And then after that, basically, we also get an idea about from the what aspect? Study of meteorites. What are seismic waves? Seismic waves we'll study in further detail when we come to earthquakes and the occurrence of earthquakes. So, whenever an earthquake occurs, there is release of energy. It is, after all, that energy which shakes the planet's surface as well. So, that energy gets actually, it is something which is emitted in all directions. And by observing those seismic waves across the planet, we get an idea about the regions from where the seismic waves have traveled and then reached us. So that is how they are an indirect source of information, because by that we are able to interpolate that what is the internal structure. Okay, magnetic field point. So when we say the magnetic field, so the planet Earth does extend a kind of a magnetic field. Now here, let us talk about, first of all, Why is it that the planet Earth does extend a magnetic field, if at all? After all, just the presence of iron and nickel will never extend a magnetic field, but planet Earth does have a magnetic field. So, why does that magnetic field exist? So, here we'll come to that, but first of all, for that you need a clear understanding about the structure. First of all, this is your surface, this is your core. This is your core. Now, as the planet rotates, outer core is in liquid state. Outer core is in liquid state. Now, as the planet rotates, this liquid will also rotate. Now, what is this liquid composed of? Liquid form of iron and nickel, which are magnetic in nature. Now, at that high temperature, the atoms, they will behave differently. The electrons will escape, will get added. So they are present in a charged state in many of the areas, or ionic state. Now, these electrons, these atoms of iron and nickel, they are rotating in the liquefied form. Now, when these materials, they will rotate, magnetic field will be produced, isn't it? Just like a solenoid in the case of your the case of physics that you would have studied, that how solenoid also subtends a kind of a magnetic field, or in electromagnetism you would have studied that when the electricity does pass through a kind of a coiled structure like this, when you pass electricity through this area of a coiled structure like this is enough to produce a kind of a magnetic field, isn't it? Similarly, just like how iron and nickel, they keep on rotating along with the planet, that produces a magnetic field. And that magnetic field, basically, it is produced somewhat like this, where the magnetic field lines, they concentrate around the region of the poles. That is where they have the maximum density. Now, that is what is referred to as geomagnetism. Geomagnetism. That is magnetism extended by Earth itself. That is what is geomagnetism. So, this is how the magnetic field is created. Now, by studying this magnetic field continuously, we get an idea about what is happening in the region of the core. For example, in the year 2020, in the month of April and May, everywhere the news headlines were reporting the same thing, that the magnetic north pole of the planet Earth has shifted ever so slightly. That magnetic north pole keeps on changing its place, keeps on reversing in direction as well. That continues to happen. But why does it shift? So understand that core, when we say it is in liquid state, it is not a liquid like water. It does not pour easily, it does not flow very easily. It is a kind of a sticky amorphous liquid. Amorphous means it can take any shape. You would have observed, or you would have seen the videos of molten iron. They are not as fluid as water. They can always exist in slight chunks and be liquid at the same time. So in 2020, when the magnetic north pole of the planet Earth shifted, at that point of time, you had a large chunk of iron and nickel on the outer core that shifted its location from somewhere like this to a new place somewhere like this. So, because of that change in density of iron from one region to another, the magnetic north pole in itself shifted. Now, you were asking that what kind of question UPSC has asked from this? UPSC has asked a question in the prelims examination that the magnetic poles of the planet, they have remained consistent since the time of its formation. true or false. So, if you know about the formation of the planet, you will always understand that everything continues to change. It keeps on evolving. UPSC has asked another question from this area, and that is the atmosphere of present day has been consistent since the time of its formation. But if you know that there was a phase of degasification, there was a phase of torrential rainfall, you would be very well aware that the atmosphere also has undergone drastic amount of changes. So that is how these are considered to be the indirect sources of information. Now, when we talk about the structure of the planet, now the structure of the planet broadly is divided into three layers. You have the solid, brittle, hard layer on the top, that is the surface, very thin, that is what is referred to as the crust. Just imagine a kind of a ripe coconut. When you take a case of a coconut, the outer surface of it is solid, isn't it? It can also be broken easily. Then that is the crust. It is the thinnest portion. Then after the brown outer crust, in the case of the coconut, you come across the white fruity part, which is also solid. But then it can change its shape. It has got a greater density, isn't it? Now, that is what represents your mantle. This is your mantle. It is also in solid, but it has got very high density. It can change the shape. Rather than getting broken, it will deform. Okay, because materials are compressed because of high pressure. Then in the interior, just like in the case of coconut, the interior portion is consisting of water. In this case, the interior portion is again in liquid form, but not the entire interior portion. The interior portion here, what is considered to be as the core, you have the outer core which is in liquid. Outer core which is in liquid state. And then inner core which is in solid state. Why is it in a solid state? We'll come to it. How gravitational pull helps to understand the interior of the Earth? Because planet Earth is not a complete sphere. Planet Earth is an oblate spheroid, where around the region of the equator it is slightly bulged. Around the region of the poles it is slightly flattened. So the distance from the center varies ever so slightly at the region of the equator and at the region of the poles. So the gravitational pull reading, the G factor that you would have studied, that is something which differs in different areas of the planet. So by that, we not only get an idea about the interior, but also the shape of the planet. How do we get an idea about the interior? By study of meteorites? Because these meteorites and meteors, which keep on moving around the sun, now they end up representing those early dust particles and early particles which eventually formed the planets. So by study of the asteroids, the meteorites, the comets, etc., we get an idea about the elements which would have been present right at the time of the formation of the planet. That is why there is such a great interest to study the comets, the asteroids, and so on. And UPSC keeps on asking you questions about such kind of explorations as well. Okay. Now, the inner core is in solid state. The outer core is in liquid state. Despite the very high temperature, the inner core is still in solid state. Why is that? Let us understand that with the help of the basics here. Let's suppose we consider a solid object. Now, this solid object, if I heat it up, it will melt, isn't it? But when this solid melts, so whenever an object is in solid state, can we not say that the molecular structure will be somewhat like this, where each and every molecules, they will be attached with each other? And when the same material gets converted into liquid state, what happens? The molecules, they become distant from each other. In a way, the material tends to expand, isn't it? That is when solid gets converted into liquid. So, can we say that when a solid gets converted into liquid due to heat, there is an expansion in volume, isn't it? So, when this will get converted into, let's say, liquid, that will bring about expansion in volume, right? Now, imagine a situation whereby this solid object is not allowed to expand at all. From all areas, I have put a kind of a obstruction that the volume expansion cannot happen. In that case, if the solid is not allowed to expand at all, then what will happen? Will it get converted into liquid? No, because the molecules, they have no place to free themselves, no place to develop a kind of a flow. So it will not melt, right? Similarly, when we talk about the portion of the inner core, above the inner core, you have thousands of kilometers of dense material lying on top of it. So by the time that you reach the inner core, the temperature is very high, but similarly, the pressure is also very high. There is no place to expand. So, regardless of the very high temperature, that expansion in volume is simply unattainable, is not achievable. And hence, what do you get as a result of that? You basically have a super hot solid substance rather than a liquid state. So, here, due to pressure exerted from the above layers, there is no place to expand. Okay? Hence, despite the very high temperature, inner core remains in a solid state. Is this understood? Why is the outer core not solid too? Because still compared to the inner core, outer core has a couple of thousand kilometers less of pressure. So that is why it has got significantly lesser pressure where it can expand. Hence it is in molten state. Okay. Is it like tabletop flat at poles? Not exactly like a tabletop, but significantly flatter. Tehseen, which last point about the inner core being in solid state? Okay. So that is where the doubt prevails. Magnetic field, Gauri, is created because as the planet rotates, the molten outer core also rotates. And the molten outer core consists of iron and nickel ions, electrons. Now, when iron and nickel electrons, they will rotate in a kind of a circular, a spiral manner, that in itself generates a magnetic field, which is referred to as geomagnetism. Okay? Inner pressure is not interacting with outer layer? Absolutely not. Contribution of geothermal gradient. Geothermal gradient is something we are aware of because of the residual heat and also because of the various sources, where geothermal gradient is simply an indication of the fact that as you go into the depth of the planet, with every kilometer, the temperature continues to increase. Magnetic field and gravitation are very different. Gravitation is exerted by any object which has mass, but any object will never exert a magnetic field. Okay. How water comes on Earth's surface? So water came on Earth's surface as a result of the phase of degassification, which led to significant cloud formation, a dense cloud formation, which brought about a phase of torrential rainfall, and that created an abundant amount of water in the form of oceans and seas. Okay. Then Saima, of the particles get stuck after collision. So that is what I had told you in the initial stages itself. Maybe you did not pay attention. Collision is of various types. If objects from different directions they come and collide, they can scatter away, right? But imagine an object moving in this direction, another object coming in the same direction with a greater speed and then colliding. So there will be heat produced at the same time that will stick together. Okay. Mainam, think about it. In which layer would we be living? Are we living in the interior of the planet or are we living on the surface of the planet? So, surface is the crust. Deepshika, temperature of inner and outer core is different? Yes, inner core is much hotter. Okay, and then Kishon, uh, indirect sources, when we say study of earthquakes, tell us about indirect sources bit briefly, other than gravitational pull and study. Okay. So when we talk about earthquakes, we will study earthquakes in greater detail in the coming days. So whenever an earthquake occurs, there is release of energy that we refer to as the seismic waves. By studying how these seismic waves they have traveled through the interior of the planet from different portions of the interior and then observing them on the surface, we get an idea about what is consistent or through which path have those seismic waves come across. Okay. Outer core is in liquid because of very high temperature. The mantle is denser form. Solid, yes, it is in solid. I have already told why China is digging a very deep hole. That is in order to explore and understand the interior of the planet in greater detail. Aman, Earth is tilted towards which direction, east or west? So basically, when you talk about, so how do you look at east or west? Our understanding of east or west is depending upon where we are standing on the planet, isn't it? From one angle, if you look at it, the seasons. So, if you take a look at the position of the planet from different angles, from this angle, if you observe, it will appear to be tilted from the west. If from that angle you observe, it will be appear to be tilted to the east. So, the tilt is the same. So, that east or west, it depends from which side you are taking a look at it. Okay. Oxygen was created much later. Oxygen was present. The oxygen, the breathable oxygen that you have, that we actually use in the atmosphere, that became predominant much later. Contribution of CO2 in the formation of the planet. There was no contribution of CO2 in the formation. When you talk about the evolution of life, so evolution of life happened because of CO2. That is how the bacterium actually started generating oxygen in the first place. Okay. Tilt of Earth is at 23.5 degrees. Devyanshi, is there any proof of documentation for planet formation? No, there is no such proof about the documentation of the planet formation because the formation of the planet is not something which happens in 2 years, 5 years, 20 years, 100 years, 200 years, 1000 years, 2000 years. Formation of the planet does not take place like that. Formation of the planet takes close to around 2 to 3 billion years. Obviously, I hope you understand that we have not been there for that time around. And even technology has not come that we would have experienced other planet forming for 2 to 3 billion years. So we do know the process by understanding the rocks. We do know the process by the various different types of information. So it is in the 1900s that we have been flooded with this information. Okay. Shargun, what is your question, my dear friend? See, I'm trying to answer as many questions. You said that in planetesimal means a large chunk of matter. So, can you tell me what kind of matter it consists of? It would consist of silicates, alumina, iron, nickel, in certain cases, water vapor as well. So, you had various different materials that it was composed of. Okay. When will you teach about Pangea? Let's see if we teach about that or not. As of now, I'm asking the question that is there any doubt which prevails till now? Okay, please don't ask me questions that when will you, obviously, we will teach that, we will cover that. Okay, so till now, you don't have any doubt. It is in the later portions that you have doubt. Okay. So few of you had a doubt about the inner core and why it is in a solid state. That is something that I will address. So basically, any solid state, any solid material, take any solid material for that matter, any solid material which exists, for that solid material to get molten or to get converted into liquid form, what is it that you require? Any solid substance. So when you have a solid substance, in this, the molecules are very close to each other. Solid substance, the molecules are closely attached to each other, isn't it? Now, for this to get converted into liquid, I hope we are aware that in the case of the liquid, the molecules are away from each other. They are not stuck to each other. So, for this to get converted into, let's say, a liquid state, the molecules they need to move away from each other, isn't it? So, when a solid gets converted into liquid, that requires an expansion of volume. That requires an increase of volume. But what if this solid is heated but is not allowed to expand at all? Let's say we have a condition where we are heating this solid, but from all sides we have put a pressure valve which does not allow it to expand at all. So, in that case, regardless of the temperature it reaches, the molecules won't be able to free themselves at all. The molecules will be stuck to each other. And that is why it will continue to remain as a solid, regardless of high temperature. Similarly, when we talk about the inner core is surrounded from all sides from very dense or highly dense materials, in the sense you don't have space to expand. That is why the inner core continues to stay in the solid state, while the outer core, which considerably faces less amount of pressure, that outer core is in liquid state. Now, after that, we move ahead with the structure of the Earth. Now, when we talk about the structure, we have the distinct layers, and these layers have distinct amount of thickness associated. And here, the thinnermost outer surface, that is what is referred to as the crust. All our lives, what you have seen till now, it is just the crust. The mountains, the land masses, the oceans, everything that represents just the crust. Okay, crust is the thinnest most portion of the planet. When you go out on the road and you observe a large rock or a mountain, immediate imagination is that there could be nothing more heavier or denser than this. This is as heavy as it can get. But understand that it is the lightest portion of the planet. The crust comprises only around 1% of the planet's entire mass. Its depth is also not significant. From the surface, depending upon whether you are in a continental region or an oceanic area, when we talk about, let's say, an oceanic area, so the depth of the crust is around 5 to 10 to 20 kilometers underneath the ocean, whereas in the case of the continents, it can be around 30 to 40 kilometers, or in general, 35 kilometers. That is all. Beyond that depth is the solid mantle with a greater density, with a greater amount of compression. That is where you have the solid mantle. Now, This mantle starts roughly around 50 to 70 kilometers below the surface. Not 5 to 7 meters, not 50 to 70 meters, 50 to 70 kilometers, right? Beyond the surface. That is where the mantle starts. Now, this mantle is in a solid state, barring an exception. So, in the portion of mantle slightly below the upper solid mantle, you have a weaker layer of a semi-solid, semi-plasticky state of mantle, right? At a depth of roughly around 160 to 200 to 300 kilometer from the surface. Okay, so in that solid mantle, at a depth of 160 to 400 kilometer from the surface. Here, you have a weaker layer of the mantle, and that weaker layer is referred to as asthenosphere. Now, why that weaker layer is formed? What is the property of that weaker layer? What is this semi-solid state that I'm talking about? We'll talk about this after the break. So right now, let's take a break, and after that, we will basically continue with the portion of asthenosphere. I hope till now things are clear. Okay. Tanishta, in recent article, I read the giant impact caused by Thea, which derived water from the outer surface. Yes. So Thea basically extracted materials from the outer surface. The portion of Sanchit, okay. Anurag, your question is, what is your question, my dear friend? See, can the outer core be referred to as a semi-solid layer? No, liquid layer. Lava is also found on the seafloor? Yes. When moon is a part of earth, why life is not found there? Because life has many other components, not just the terrain. You need atmosphere as well, and moon doesn't have a significant atmosphere. Okay. Is the asthenosphere absolute upper portion of mantle? No, it is slightly lower than the upper portion. Dhanraj, which portion of the formation of Earth you did not understand? For everyone, I would suggest this. See, it is very simple to say that I did not understand that topic. Repeat that entire topic again. But I want you to be able to pinpoint. There would be a concept, there would be a sentence from where your understanding would have weakened. Pinpoint that particular area. That what is it that did not make sense to you? Once you are able to do that for any subject, you will be able to clear your doubts much easily, and you will also be able to get a clearer idea about the portions which you have understood. Okay, right? So we take a break now, and we come back at 7, and then we continue. Okay. Ashwin, you said that uranium is not present initially. When was it deposited on Earth? At later collisions from the asteroids, meteors, that is when it is estimated that uranium got impregnated on the planet. Chinmay, my dear friend, you have taken up directly a PYQ. I will come to that. Break till 7:02 p.m. Abdul, the theory that we have talked about right now about the formation of Earth, that is the accretion theory. Okay. If my hmm, Venkatesh, maybe your doubts are so very heavy, but on a serious note, the comment section is filled with various different things that my doubts are not taken. But please understand my limitation as well. Okay. And already I have Chavan and Anushka saying that Vivek, your question is doubt in the rotates. The liquid outer core also rotates. And when the liquid outer core will rotate, imagine what the liquid outer core is made up of: iron and nickel. So when the iron and nickel particles they rotate in a spiral or a circular motion, that produces its own magnetic field where the planet starts behaving like a bar magnet. Now, any point of time when there is a significant chunk of the outer core consisting of iron and nickel, when they slightly shift from one location to another, or when the dominance of iron and nickel suddenly increases in other portion of the outer core, the magnetic poles they undergo a change, they undergo a shift. Deepa, your query is still not something that I have seen till now. um, Javaria, initially Earth was in molten state, so inner core was also in molten state as the solidification or cooling started from the outer surface. Then how does the inner core solidify first? The inner core eventually has been in or was created as a solid state due to the immense pressure exerted from above, where the inner portion that differentiated itself from the outer core. The outer core was made up of comparatively lighter substances as compared to the inner core. Even though both of them are dominated by iron and nickel, but still there would be a slight mass difference. And that differentiation that separated the outer and inner core, and that led to the solidification of the inner core. Kirtana, degasification is that phase in the evolution of the planet Earth when all the gases trapped in the interior they emerged outside along with the molten materials in the series of endless volcanic eruptions, which led to these gases escaping from the interior, hence degasification. Okay, is there any mixing of the inner and outer core? Muni, no. We'll come to discontinuities, and there you will be able to understand that. And change in the pole happened due to the change in composition of nickel and iron, the concentration of iron and nickel as they shifted. Can core be solid in future? Yes, in long term future, in billions of years, eventually as the residual heat is lost, it can get converted into solid. Okay, and today we have the oldest version of the atmosphere, but what exactly was the early atmosphere? We'll come to it when we come to climatology, Somilia. Does the changing magnetic field impose any change in the weather or climate? Not exactly in the weather or climate, but you have certain changes in terms of the charged particles emitted by the sun. Where do they incident upon significantly in greater concentration? And also the compass readings, they end up changing. And uh, how many kilometer crust from the surface? Yeah, we have close to around 35 to 50 kilometers of thickness. And then are we having any disadvantage of outer core being in liquid? No. Um, Anurag, in which subject will we study about evolution of life, dinosaur age? That is not required for your examination, my dear friend. Why will you study about when is it that dinosaurs came in? Dinosaurs, they were in existence close to around 250 million years ago, and they went extinct close to around 65 million years ago. You do study about the various mass extinctions, speciation in the portion of environment and ecology as much as is relevant for the examination. Okay, I hope, Anurag, that solves your query. And change in magnetic field affects when a satellite is launched? Slightly, yes, Asta, but not significantly. If density and temperature of inner core is more, then why it does not explode? Coil, because it has no place to expand at all. From all around it, it has got so much of pressure that it cannot expand at all. And geomagnetism, Kavya, the process of Earth behaving like a magnet or extending that magnetic field, that is geomagnetism. Hypothesis, Ghulam Mustafa, is any postulation that you put forward, any theory that you put forward, that is hypothesis. So, in the case of the moon, that is where the giant impact hypothesis explains about the formation process of the moon. Okay, so the giant impact, the impact created by Thea. Rashida, that is correct. And okay, we have covered that. Magnet of planet is opposite to the core. I'm unable to understand the question, Bhagya. Did all the planet formation took place? Majority of them, Kumari, yes. Ozone layer, Sahil, got created much later. Liquid in outer core moves with Earth or opposite to the Earth? It moves along with the Earth. So we can say that heavy rain further cools surface, make cracks, it will fill with rain formed oceans. Yes. Is Thea responsible for the tilt of the Earth? Slightly, yes. But majorly the tilt has been created due to the oblate shape of the Earth. Okay. And while Earth was going through evolution of atmosphere, why didn't Moon show same changes? Moon also showed significant changes ever since its formation. But you have to understand that the Moon's gravitational pull is much lesser as compared to the Earth's gravitational pull. That is why significant amount of materials or gases they would escape the Moon's atmosphere. That is why Moon's atmosphere is not nearly as dense as you have in the case of the Earth. Okay. Astha, what type of pressure wall is present around the inner core? So just think about it. All this pressure, think about it. A small rock, you try to lift it up, put it on your head. Now it will exert some pressure. Put a larger rock, it will exert greater pressure. Imagine if you have 5,000 kilometers of those rocks upon you, the amount of pressure exerted. That is something which is felt at the region of the inner core. Okay. Gravitational force is the force of attraction exerted by any object with a mass. So the gravitational force of the Earth is something that keeps us on the ground, is something that basically keeps the atmosphere stuck to the ground. Okay. I hope now nobody will basically provide an allegation that I'm ignoring them. I hope now that we have taken enough amount of questions. Magnetic forces of the Earth are created due to the rotation of the outer core being rich in iron and nickel. When they end up, the iron and nickel particles, when they end up rotating in a circular or spiral manner, that exerts a kind of a magnetism that we refer to as geomagnetism. Has Sun got greater gravitational pull than the Earth? Obviously, yes, because Sun has got a much greater mass as compared to Earth. Okay. See, this is where the difference comes. Those of you whose questions have been answered, you are urging me to move ahead, but the rest of you, you are okay. Few more questions I will take. And are the climate and weather the same? No, they are different. Does the charge of north and south magnetic fold keeps changing or is constant? It keeps on changing. Recently, it was said that Earth's core has stopped moving. No, that is not the case. And Shama, my dear friend, please put your question at the end of the session. How the moon got cooled down, just like the planet Earth. It started losing temperature from outside. Okay. Uh, right? Is the Earth tilted towards the sun or away from the sun? If you look at from one perspective, it will appear to be tilted towards the sun. If you take a look at it from other perspective, it will appear to be tilted away from the sun. It is not as if, so from which side are you looking at it? Understand that. Okay, just detach yourself from planet Earth when you are imagining it and think about it that at one point the tilt will always appear away from the sun, at some point it will appear towards the sun. Okay. Right? Jupiter has more gravitational force than the sun? Absolutely not the case, my dear friend. Abdullah. Jupiter has not got a greater gravitational force as compared to sun. Sun has got, if Jupiter would have had a greater gravitational pull, then Earth would have started revolving around the Jupiter. It is the gravitational pull which brings about revolution across the planets. Okay? I hope that is understood. Okay. Planets also pull each other when they're with their gravitational pull. Yes, Jupiter does extend its gravitational pull to the Earth, which provides a slight a kind of an eccentricity in the orbit, elliptical orbit of the planet Earth. Okay. What happens on aphelion? Like that time, our Earth is far from the sun, so it shows that we will not feel high temperature. Absolutely not like that. Absolutely not like that. See, the distance between aphelion and perihelion is only around 3 million kilometers. That difference. That is the solar rays traveling through space. It is the solar rays traveling through the atmosphere which creates all the difference. Again, I am telling you about climate, weather, heating, cooling, seasons, temperature. We will come to climatology. We will talk about it in greater detail. Okay. Neptune have all the objects, all even this pen will have a gravitational pull of its own. Understand the basic principle of gravity, something that Newton discovered close to around 500 years ago, right? Gravity is extended or subtended by any object which has got mass. Okay. Why Saturn have ring-like structure and others don't? So it is not only the Saturn which has got a ring. Neptune also has got a slight ring. So it again is created due to the impact whereby many materials they are uh, sent away from the planet and then they are held by the planet's gravitational pull of attraction. Okay. Now, after this, we move ahead. Now here, when we talk about the region of the mantle, so, in the region of the mantle, immediately, if I have to explain it with the help of a simple image, a schematic diagram, here, if let's suppose this is the crust, obviously it won't be uniform. Let's suppose this is the limit of the crust. Let's suppose up till a distance of around, let's assume 50 kilometers. Now, underneath it, you have the mantle. This is where the mantle starts. Now, after you reach around 160 to 400 kilometers from the surface, at that depth, the region of the mantle, for a significant proportion, is in semi-solid or a plasticky state. It is not a complete liquid, it is not a complete solid, it is a semi-solid plasticky state. What do we mean by a difference between solid, semi-solid, and liquid? So when we say liquid, it can flow. When we say solid, it is rigid. But semi-solid or plasticky is somewhere in between, where it is partially molten but not completely liquid. Right? For example, I'm sure in your childhood days, you would have played with your plastic ruler or any plastic object. Now, when you would heat that plastic object, you would have observed that it tends to expand. It can be stretchable, but it is not a complete liquid either, or neither is it a complete solid. So, that is the structure in that portion of the mantle, okay, that exists in semi-solid or plastic state. Okay, so this is a weaker layer present in the upper portion of the mantle. Not exactly in the uppermost portion, but in the upper portion of mantle. Now, that is where at a depth of 160 to 400 kilometers from the surface, materials exist in semi-solid state. Solid, weaker state. And this is a layer which is referred to as asthenosphere. It is derived from the term astheno, which means something which is weak. So that is where you have the asthenosphere. Now, this is your asthenosphere. Now, this asthenosphere is a source of all the various different volcanic eruptions that you come across. The lava that comes out, the molten materials that come out, they are supplied from the asthenosphere itself. But here the question arises, is that why, when the entirety of the mantle, when we talk about the mantle in the uppermost portion, that is also solid. When we talk about the mantle beneath the asthenosphere, that is also solid. So why is it that suddenly in between you have a layer which is semi-solid or slightly molten? That is because at this particular depth, you have a sudden abundance of radioactive materials. When we say radioactive materials, we are talking about materials such as uranium and isotopes of potassium. So they are present in abundant quantity. Okay. So first of all, abundance of uranium and potassium. So that abundance of uranium and potassium, understand, already the temperature, as you go every kilometer into the depth, the temperature keeps on increasing, sometimes by 20 degrees Celsius per kilometer, sometimes by 25 degrees Celsius per kilometer. It keeps on increasing. So already by the time that you are at a depth of 160 to 400 kilometers, the temperature is significantly high enough. To add to that, there is a pressure exerted by all those heavy rocks from above. So under these conditions of high temperature and high pressure, these materials, they undergo a thermonuclear reaction under the conditions of high temperature and pressure. Materials undergo thermonuclear reaction. Now, whenever a nuclear reaction takes place, I'm sure you would have read your basic elementary science in your class 7th, 8th, and 9th and 10th standard. So, I hope you are aware that whenever a nuclear reaction takes place, what do you think? Heat is produced or heat is consumed? What do you think? Is the heat produced or is the heat consumed? Good. Now that Oppenheimer movie has also come out, I think nuclear reaction is something that all of us would be aware of in greater details now. Okay, so heat is produced. Whenever a nuclear reaction takes place, heat is an outcome. That is why you have the generation of electricity from nuclear reactors as well. That is something that you observe in the case of a nuclear explosion as well. That is what you observe in the case of sun as well. Sun is a case of nuclear fusion. But here, nuclear fission reaction takes place. Nonetheless, nuclear reaction takes place that produces very high temperature. And that very high temperature which is produced in that region, it ends up partially melting the materials present in that region. Okay, so it partially melts the material present in the region. So that is why asthenosphere, which is present in the upper portion of the mantle, that is in semi-solid or a semi-liquid plasticky state. And that is why it is referred to as asthenosphere, because asthenosphere refers to a kind of a weaker layer. So observe here, at a depth here, initially you have the lithosphere. Now, what is lithosphere? Lithosphere is considered to be the part of the crust and the solid portion of upper mantle. That is what is lithosphere. I'm writing everything down so that it is easier for you when you revise, but please do revise. It is the solid crust plus solid upper mantle. Okay, that solid crust plus the solid portion of the upper mantle, that is what is referred to as lithosphere. Underneath that lithosphere, you have the weaker semi-solid plasticky layer, that is the asthenosphere. Why is it semi-solid? Is because there you have a sudden abundance of radioactive materials such as uranium and potassium. So these materials under high temperature and high pressure, they undergo a thermonuclear reaction. And that produces so much amount of heat that you have the partial melting of materials in that region, creating that region of asthenosphere. Okay. Now, this is basically about the overall structure. Now, let us take a look at these individual layers one by one. And this is the written text of it. So, when we talk about crust, the solid uppermost portion, which is very brittle in nature, brittle means something which breaks easily. Whenever there is significant amount of compression, expansion, any amount of tensional force, compressional force, it will break easily. So that is what is consisted of in the crust. So it is the outermost solid part of the earth. It is brittle in nature, and this represents only around 1% of the mass of the earth. Now, the thickness of the crust is not uniform. Under the continental areas, you will find the crust to be much thicker. Under the oceanic areas, the crust is much thinner. Now, depends upon where there's a greater compression, etc. Having said that, you have to understand that the mean thickness of the oceanic crust is only around 5 kilometers, whereas the mean average thickness of the continental crust is around 30 kilometers. But it varies from place to place. For example, in the region around Himalayas, where there's a significant amount of compression happening from both the sides, there the crust has thickened up till around 70 kilometers, right? So continental crust is thicker in the region of major mountain systems, where it can get to a thickness of around 70 kilometers, for example, in the Himalayan reaches. Now, observe here, this is the depiction of the continental crust. This is the depiction of the oceanic crust. Okay. Now, it is generally the continental crust that is dominated by silica, alumina in general, right? So, it is also sometimes referred to as the Sial layer. But then you don't have to get into it. Just understand it is chiefly dominated by the granitic rocks, which have a density of only around 2.6 to 2.7 gram per centimeter cube. So that is the density. Every centimeter cube weighs around only 2.7 grams. Whereas in the case of the oceanic crust, which is dominated by magnesium, iron, and silica, etc. So oceanic crust has got a greater density. 2.9 to 3 gram per centimeter cube is the density of the oceanic crust. So despite the fact that the continental crust is thicker, and listen to this carefully, despite the fact that the continental crust is thicker, oceanic crust is thinner, still it will always be the oceanic crust which will be heavier. So oceanic crust is always heavier. Oceanic crust is always heavier as compared to continental crust. And why is that the case? Because the density is high due to greater density. Why is the density high? It is made up of primarily different types of materials. The continental crust that you will come across is made up of granitic rocks, which will be more dominant in silica, more dominant in alumina, whereas the oceanic crust will be dominated by magnesium, iron, and basaltic rocks in general. To understand this, take a simple analogy of a thermocol and iron. So let's say you take a larger block of thermocol, let's assume, and you take a thin sheet of iron or steel. Now, despite the fact that the thermocol is very thick, still, as compared to iron, which will be heavier? Always iron will be heavier. Regardless of the thickness, thermocol will always be lighter. Why do you think that is the case? If thickness would be the factor to determine the weight, then thermocol would be the heaviest, but it is not so, it is light. Why? Because the density is very less, isn't it? So that is the same analogy which plays out in the case of oceanic and continental crust as well. So always remember, and this is one of those facts which is mentioned incorrectly in NCRT. So when you would be studying your NCRT, these figures are interchanged. So be very clear or be very careful when you are revising this with the NCRT, because NCRT has, amongst the many errors that it has, this is one of the errors that NCRT has not fixed till now. So always remember, oceanic crust is made up of denser materials, and that is why it has got greater density. Due to that greater density, oceanic crust will always be heavier. Regardless of the thickness, oceanic crust is always going to be heavier. I'm sure I will have the same question asked to me tomorrow as well, and day after tomorrow as well. But still, I would again tell you that oceanic crust is heavier. Why? Because the density is greater. Why is the density greater? Because the materials which, for example, magnesium and iron, they dominate it. Whereas the continental crust dominated by the lighter materials, and hence it has lesser density, and hence it has got lesser weight as well. Okay. Why the crust is thicker around the mountain systems? That is because majority of the mountain systems have been created due to compression. So imagine if you have, let's say, a particular layer. Let's suppose, let's consider this. Now if this is compressed from both sides, what will happen? It will thicken significantly, isn't it? So that is the same phenomena happening in the case of the mountain systems as well. That is why they have a thicker case. Okay. Now here, after this, we come to the portion of mantle. So when we talk about mantle here, it is the layer which starts immediately below the region of the crust. And it is not uniform that everywhere mantle will start at the same depth. In certain areas here also you can observe that the crustal thickness is more, here the crustal thickness is less. So it varies. But in general, immediately below the crust, the mantle is something which is to be found. And this is the bulky portion, because if you observe here, mantle extends immediately below the crust and continues up till the outer core, which is at a depth of close to around 3000 kilometers, not 3000 meters, 3000 kilometers from the surface. So think about it. It starts roughly around 50 to 60 kilometers below the surface, that is the mantle, and extends almost up till 3000 kilometers. So it is very bulky, and it represents close to around 68% of the Earth's mass. Average density of the mantle is around 3.4 gram per centimeter cube. That is, the density is much higher than the crust, and it increases as you move from the upper region of the mantle to the lower region of the mantle. Why is it that the density will increase in the lower region of the mantle? Because the upper portion of mantle will also exert its weight, pressing the material further down. So that is why density keeps on increasing as you move from upper portion of the mantle to the lower portion. So density. is higher than crust increases as we go to the depth of mantle. In fact, in the lower portion of the mantle, the density sometimes can be as high as even 6 gram per centimeter cube. It is just the average of the entirety of the mantle coming from the portion immediately beneath the crust all the way till 2900 kilometers. That density on an average is 3.4 to 3.5 gram per centimeter cube. Now, in the region of the mantle, that is in the upper portion of the mantle, here that is what is referred to as the asthenosphere, derived from the term astheno, which means weak. It is considered to be extending up till around 400 kilometers in depth, and it is the main source of the molten materials or magma that eventually erupts from the surface during any volcanic eruption. Now, why is the asthenosphere in that particular state semi-molten, semi-solid? Because of presence of thermonuclear reaction. And why does the thermonuclear reaction take place? Because of the abundance of materials like uranium and potassium. Okay. Further down as we move, there we come across the core. Now, core is dominated by iron and nickel, and that has been the case ever since the formation of the planet itself. Core also ends up representing close to around 31% of the Earth's mass. Now, here the outer core is in molten state, the inner core is in a solid state. Why is the inner core in a solid state? Because the external pressure acting on the inner core does not allow the inner core to expand even slightly for that to exist in liquid state. Hence, despite the very high temperature, inner core continues to remain in a solid state. And core is made up of very heavy materials, mostly constituted by nickel and iron, and hence it is also what is referred to as the Fe layer. Ni stands for nickel, Fe stands for iron. Hence it is referred to as the Fe layer. Okay. Now, after this, we come to something which is referred to as discontinuities within the layers of the Earth. Now, what do we mean by the discontinuities? So basically, think about it. The kind of rock surfaces that you find on the surface. If you imagine the bottom of the crust, the surface of the rocks or the type of rocks, obviously their density will change. Their arrangement of the particles will also end up changing, isn't it? Because the pressure will change, the temperature will change. So, even within the region of the crust, you will have a distinct nature of the materials as you go to a depth as compared to the surface. Then, when you compare the surface or the materials of the crust and the materials of the mantle, they will also represent a remarkable shift or a change. So, that change in the materials, in their structure, in their density, in their particle arrangement, all of that aided by temperature and pressure at the depth, that is demarcated by a line of discontinuity or a discontinuity in general, right? So, I will write it down separately, but first of all, understand this. Again, I will reiterate and again, I will repeat. When we talk about the various different layers, the particles, their nature, the arrangement, the molecular structure, everything keeps on changing as we go to the depth. Now, upon reaching a depth of any layer or within different layers, that sudden irregular change in the particle structure, in the molecular arrangement, aided by temperature and pressure, is known as a discontinuity. And these discontinuities are present in the region of the crust, are present in the region of the mantle, and are also to be found in the region of the core. So, for example, the discontinuity which separates the outer and the upper crust and the inner crust, that is what is referred to as the Conrad discontinuity. Then, the discontinuity separating crust and mantle, differentiating the materials and their particle arrangement, that is what is referred to as the Mohorovic discontinuity, or simply referred to as the Moho discontinuity. Then similarly, in the upper portion of mantle and inner portion of mantle, that is differentiated by the Repeti discontinuity. Then the region of the mantle is separated by the molten outer core by what is referred to as the Gutenberg discontinuity. And eventually, the molten form of outer core is differentiated from the solid form of inner core by what is referred to as the Lehman discontinuity. So, these are your different types of discontinuities which are in existence. So, when we say discontinuity, here the sudden change in particle structure, arrangement, density, etc., aided by changing temperature and changing pressure. That is what is known as a discontinuity. So you have the Conrad discontinuity separating the upper and the lower crust. Okay, that separates the upper and the lower crust. Mohorovic, okay, Mohorovic discontinuity, or simply referred to as the Moho. In geographical terminology, you will come across that this earthquake struck 50 kilometers underneath the Moho, or this earthquake struck at the with a focus at Moho. So whenever you come across the term Moho, it stands for Mohorovic discontinuity, and that differentiates the crust and the mantle. Then you have the Repeti between the upper and the inner mantle, and then you have the Gutenberg differentiating the mantle and the core, and you have Lehman discontinuity differentiating the outer core and the inner core. Now, out of all of these, important ones for your examination, for your general studies perspective, is going to be Moho and Gutenberg. These are going to be the important ones. Okay, these are your important ones for your prelims that you should be aware of. Now, here, when we talk about this particular area or the portion of the structure and the layer of the earth, there is another area from where UPSC tends to ask questions in prelims, and that is about the abundance of elements present in the interior. So when we talk about the various different elements present in the interior, their concentration varies. So this is something which is relevant for your prelims examination. Okay, so here, when you take a look at it, minerals in the interior of the earth. So when you consider earth as a whole, okay, whenever you consider earth as a whole object, iron is the most abundant element, followed by oxygen. And we are not talking about atmosphere here, we are talking about the earth. How is it that oxygen is so abundant? Oxygen, after all, is a gas. So how is it that we say that oxygen is the second most abundant element in the entirety of Earth's structure? What do you think? Very good. In the form of oxides. So the oxygen that you see here, that exists in the form of oxides. So that is where iron is the most abundant, followed by oxygen, followed by silicon, followed by magnesium. Ideally, for your examination, the top four need to be recalled. Okay, you should be aware of the top four. But when you consider only the Earth's surface, not the entirety of the planet Earth, only the surface, only the top of the crust. So there oxygen is the most abundant, followed by silicon, aluminium, and then comes iron. So again, top four, you need to be recalling that for your examination perspective. Okay, so this is basically your minerals in the interior, structure, the layers of the earth, their properties, as well as the sources of information, that how we get an idea about these layers and the structure and the formation also we have taken a look into. Now we come to the portion of rocks. So when we talk about rocks here, this is going to be relevant in terms of its very basics. Okay, the basics of rocks, that is something which is required both for your prelims as well as for your mains exam. Okay, because this year in 2022 in the mains exam UPSC did ask a question about the rocks. Okay, so that is something that you should be aware of. Now, last slide. This is something written in the slide itself. So these types of coverage is not given in the NCRT. Obviously not, my dear friend. Otherwise, what is the point of attending the live class if everything is being taught from the NCRT itself? Where do you get that additional source of information? That is why you attend the class, isn't it? So, when we talk about rocks here, what are rocks? Something that we encounter on our day to day basis. The moment you step outside of your house, you will encounter or you will observe some or the other rock type. So, what are these rocks? The rocks which make up the land surface itself. So these are basically an aggregate of various different compounds, elements, and minerals kept together, solidified together. Now, based upon how they have come into existence, you have the various different types of rocks. So when we talk about rocks here, they are mineral aggregates with a combination of properties of various different elements taken together. Now here, each of these rocks, they will have their own properties depending upon the mineral which is dominant. Certain rocks, they will exhibit a kind of a magnetic property because maybe iron is very dominant in that. Some of the rocks, you'll be able to break them with your palms and with your own hands as well because they are softer, because they are made up of materials which can easily get crushed, right? Like calcium. So that is how you have the various different types of rocks and their individual properties. Based upon their very formation, you have three different types of rocks: igneous, sedimentary, and metamorphic. What are they? How are they created? And what is their distinct feature? So, when we say an igneous rock, igneous means what? Originating or associated with fire, associated with very high temperature. So, when molten materials they cool down and form the rocks, they are referred to as igneous rocks. So, whenever a volcanic eruption takes place, the molten materials they spread out. You would have observed it in various videos, etc., and images as well, that molten materials they start spreading out, and these molten materials then start to cool down, and eventually they solidify to form a kind of a rock, some or the other kind of a rock. That is your igneous rock. Okay. Now, various things can happen. Sometimes it can also happen, let's suppose this is the surface, and the surface is not very hard, the surface is weak, right? So, molten materials, let's say you have a pocket of molten materials, these molten materials, they will break through the land surface and they will create a kind of a volcanic eruption. Molten materials will spread out and they will solidify. But sometimes the molten materials, let's suppose here the rock is, or there is a large mountain like Himalayas, and the molten materials they are unable to come to the surface. So they will solidify in the interior itself. In the region of the crust or the upper mantle itself, they will solidify. But that solidification process will be very slow. So, depending upon where that solidification takes place, you have a categorization of igneous rocks as well. When you have the molten material solidifying on the surface, that is what is referred to as extrusive igneous rocks. Extrusive igneous rocks. And when they solidify in the interior itself, right, let's suppose they have solidified in the interior itself, they are referred to as intrusive igneous rocks. Intrusive means on the inside. So, whenever molten materials solidify, they will form igneous rocks. Now, can we say that igneous rocks, they are referred to as the primary rocks? Can we say that? Will that statement be correct or will that statement be false? Let me know. Don't think much about it. Don't worry whether you will be wrong or correct or not. Just whatever is your instinct, express that. Right? Okay. So, majority of us, we have said that it is correct to say that they are the primary rocks. What do we mean by primary? Means the first kind of rocks. So, when the planet was solidifying, when the planet was getting created, during the phase of degasification, all the molten materials would come out and they would solidify. And that is how the rocks would be created. So, igneous rocks, whenever a new landmass is created, it is always in the form of igneous rocks. That is why igneous rocks are also known as primary rocks, the first kind of rocks, the basic kind of rocks which have been created. If you have understood this point, you'd be able to answer the question which was asked in the mains examination for 2022, where the question was, what do you understand by primary rocks? Discuss about its types. Now, majority of the candidates, in the name of primary rocks, they thought that all the basic rocks, they are referred to as primary rocks. In fact, till today, you do have videos of various different tutors, coaching institutes, etc., who will advocate at great length that how primary rock consists of all the three types. I'm I'm not criticizing anything here. I'm just telling you that follow the logic. Don't believe what I say. Don't believe what the book says. Follow the logic. Wherever there is a logical standpoint, even in the case of the mains answer, that is what distinguishes the successful candidates from the unsuccessful ones. The successful ones, they apply their logic at that point of time. That if UPSC is asking about primary rock, maybe I have not read about it. But what do you understand by primary? Something which is very basic, something which is formed in the initial stage. So, which is that rock? Igneous rock. So, they would answer that question like that. Okay. So, igneous rocks, they are formed by solidification of molten materials. There is a written portion in this PPT as well. Don't worry about it. You will get that. Now, coming to the sedimentary rock. We will explain and talk about the igneous rock again. So, don't get into a hurry. Sedimentary means what? Sediment is one of the key terms in this. Sedimentary. What is a sediment? Sediment is a deposit, any kind of deposit, brought by the rivers chiefly, brought by the winds in general. So, over a period of time, and do this thing at your own house. You can practice this or you can do this experiment even at your own house or at your, if you don't want to get a scolding from your house, do it at your friend's house or your cousin's house so that you are safe. So, you can do this experiment where take an old flowering pot, right, where you have some soil. Now, there don't plant any or don't put any plant there, don't put any seed there. Let it remain outside and let it remain there for a few months undisturbed. After a point of time, when you try to touch that soil, it becomes very hard, hard as a rock. Why does that happen? So, when you have deposits, deposits by anything, right? Let's say you have deposits. Now, these deposits, on top of it, with the passage of time, more deposits will take place, more depositions will happen. Yes, very good, Ananya. More deposition will happen. With the passage of time, much more deposition will happen. Eventually, what will this lead to? A series of various different types of deposits. Now, the top layer will exert its weight over the bottom layers, isn't it? It will always exert a weight. It will add on to that compressional force, what is also referred to as compaction, isn't it? There will be significant amount of compaction. Everything will be much more compact and concise. Eventually, through a process that is also referred to as cementation, they will solidify, where the various different minerals, they will combine with each other, they will solidify, and they will create a rock, and that is the sedimentary rock. So that is how sedimentary rocks can be created. So it can get created by the existing rock, they getting eroded, and those deposits forming another rock, or various different deposits combining together to form a kind of a sedimentary rock. So that is how they are created, by solidification of deposits. Solidification of deposits. Then what do we mean by metamorphic? Metamorphic is derived from the term metamorphose. And I'm sure you would be knowing the meaning of, if even if let's assume you don't know the meaning of metamorphose, what do we understand by metamorphose? Where you change the shape, the characteristic, the very nature. So when any existing rock type, when it is exposed to very high temperature or very high pressure, the particles, the molecules, they change their state, they change their shape, and that is how they change their characteristic. And that is how eventually you have the metamorphic rock. For example, the marble that is used in your floorings, in the construction purposes, even Taj Mahal, constructed out of marble. Now, marble is a metamorphic rock. It is created out of limestone. Limestone is a sedimentary rock. When it undergoes significant amount of pressure, compression, significant amount of exposure to high temperature, it changes itself into marble. If you look at limestone, it is a very dull looking grayish colored stone. But when you take a look at marble, it is something completely different, isn't it? So that is where metamorphic rock basically comes in. So here, rocks, when exposed to high temperature and high pressure, undergo a drastic change. Okay, let us take a look at the examples and the types of it. But before looking at the text, I want you to take a look at the image here. This is an igneous rock. Observe the image here. Here, you'll find a kind of a uniformity in terms of the texture, in terms of the material which is present. You'll find a kind of an existent uniformity, isn't it? What does that signify? That all these would have solidified at once. There is that kind of a uniformity. And all of this would be consisted of the same material. So basically, igneous rock is formed through the cooling and solidification of magma or lava. That solidification can happen in the interior or can happen on the surface. When it happens in the interior, it is also referred to as the intrusive, right? Or the plutonic rocks. Whereas when it happens on the exterior, it is also referred to as the extrusive or the volcanic rocks. Okay. Now let me ask you a question here. Basically, if I give you two instances, apply your logic again. So if I give you two instances, one is the case of molten materials cooling down in the interior. Let's represent this case by A. One is molten materials coming to the surface and then solidifying. Let's represent this by case B. Now, out of A and B, where do you think the solidification process will be faster? In the interior, that is A, or on the exterior, that is B? Beautiful. Very good. Very nice. It will be exterior. It will be the case B. Why? Because B is exposed to the outside atmosphere, which is much colder. And this is cooling down in the interior where the interior is already hot. So the cooling down process will also be slow, isn't it? So that takes us to another concept. Slowly, we will come to another concept. So here we know that cooling down is faster. Rate of cooling is very fast. Rate of cooling is very slow. Okay. Now, if the rate of cooling is very fast, the particles, will they be able to make multiple linkages with the different bonds or the different particles which are present? No, because they will solidify as quickly as possible. Whereas when the rate of cooling is slow, each of the particle, they will develop as many bonds with the surrounding particles as possible. They will develop a bond here, 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 so on. They will keep on developing as many bonds as possible. Whereas if the rate of cooling is fast, maybe they will be attached with one particle or another, and that is it, and they will solidify. Isn't it? That is why when you observe the intrusive igneous rocks, their crystals, each of the particles, they are larger in size because they have cooled down very slowly. So each of the particle has grown larger in size while solidifying. Whereas in the case of the extrusive, because they have cooled down suddenly, the particle size is much smaller. So, intrusive igneous, when we talk about the intrusive igneous rocks, here they have larger crystals as, or simply put, or grains as the cooling process is very slow. Example, diorite, pegmatite, etc. Pegmatite is the ore from which you extract an important mineral, that is mica. Mica is extracted from pegmatite. Then when we talk about extrusive igneous, they have cooled down very quickly. So these rocks erupt onto the surface, resulting in small crystals as the cooling takes place very quickly. Basalt, tuff, pumice, etc. These are the examples. Okay, I hope this is understood. Right? Now comes the sedimentary rocks. Now here, again, I want you to spend some time observe the image. Now this image differentiated with as compared to that of igneous rock. In igneous rock, you find a kind of a uniformity, isn't it? You find a kind of a uniformity. Whereas here, you don't have that uniformity. You have a separate material which is engrained here, a separate material which is present here, a separate material which is present here, here, and so on. So, what does that tell you? It tells you that there have been various deposits which have solidified. Now, these deposits would have taken place over a period of hundreds of years, maybe thousands of years, in certain cases, maybe millions of years. So, this is what is sedimentary rock. Now, think about it and then understand. When we talk about sedimentary rocks, it has got multiple different particles ingrained in it, so multiple different bonds, etc. Whereas igneous rock is composed of only one type of material. So, which will be harder to break, igneous or sedimentary? Which of them do you think will be harder? Very good. It will be igneous, because igneous has got a uniformity. Here you have so many different hodgepodge mechanisms done, it is very easy to break. That is why whenever you observe in history and art and culture, you study the portion of Mughal architecture. I'm sure you would have covered the portion of history already. Now, majority of the architectural buildings constructed by the Mughals, be it the Agra Fort, be it the Red Fort, any of those that you pick, be it the Fatehpur Sikri or Akbar's tomb at Sikandra, majority of the constructions you will find is dominated by red sandstone, which is a sedimentary rock. Why? Because it is easier to carve in these rocks. It is easier to break and create designs in these rocks. Whereas in the case of igneous rocks, it is almost impossible. The most clear cut difference in the architectural engravings that you observe, all those of you who have been to Delhi, there are multiple other places where you will observe this as well. So I don't want you to get sudden regional pride that you have mentioned about Delhi. What about my region? In my place also you have this. Understand. So in Delhi, there is this place, Hauz village, right? Again, created by the Tughlaqs at that point of time, and even during the time of Khiljis. Now, there you will observe that you have the older ones created during the later 1200s. That is constructed out of igneous rock. Next time when you visit Hauz village or you take a look at the images of Hauz village, you will observe that you have few of the buildings and few of the construction which has got absolutely no design. Very simple construction, because they are constructed out of igneous rocks. And the later part of Hauz village, which was constructed during the 1300s, that uses sedimentary rocks. So there you will observe very intricate designs laid out. That is because sedimentary rocks are much softer, much easier to break. Why easier to break? Because they themselves have been formed by a combination of different materials. Now, if I ask you another question, out of the sedimentary rock and igneous rock, where is it that you will have a greater probability, or rather, where is it that you will find the fossils of animals and plants? In the case of sedimentary rocks or in the case of igneous rocks? Good. In the sedimentary rocks. So, all the fossil remains that you find, all the animal and the plant remains that you will find it in the sedimentary rocks. You will never find it in igneous rocks. Why? Because the igneous rocks have been formed by the solidification of molten materials, where sedimentary rocks, they have been formed as deposits. So it might absolutely be possible that after one deposit you had a dead animal, and then further deposits, they have fossilized that. That is the precise reason how and why we do know for a certain fact that the place that we call Himalayas right now, many portion of that was at one point of time underwater, because we have remains of marine animals to be found in the higher elevated areas of the Himalayas. How could they have reached there? They could have reached there only because it would have been underwater at one point of time. Now, when we talk about this sedimentary rock, is again classified into various types depending upon how they have been created. So, the process of formation of sedimentary rock in itself is something which is very different in various cases. How? So, let us assume you have an existent rock type. Let us assume an existent igneous rock type. Now, this particular rock type, over a period of time, will get exposed to sunlight, heating by the sun, will get exposed to extreme cold conditions during the night, will get exposed to very heavy rainfall, will get exposed to dry conditions. Over a period of time, expansion will happen, contraction will happen during cold conditions. The rock will weaken. It might break down. Its mechanical strength might weaken, and the existing rock type might break down in the form of various different deposits. Eventually, these deposits might solidify to form another rock altogether, isn't it? That will be called a sedimentary rock because it has been created due to the deposits, hence a sedimentary rock. So, here, when we talk about the types of sedimentary rock, you have three types. One is what is referred to as the clastic sedimentary rock. What is a clastic sedimentary rock? So they are formed from the mechanical weathering debris where the existent rock has broken into small parts. They have been deposited. Those deposits have solidified into a sedimentary rock. That is clastic sedimentary rock. Example, sandstone. Sandstone created how? By the solidification of deposits of sand, right? So wherever you find sandstone, at one point of time in the geological history of that place, there would be abundant amount of sand. Then you have silt stone. What is silt? So the river, the deposits that the river brings, that is what is referred to as silt. So those deposits, they get created into silt stone. So this is what is referred to as a clastic sedimentary rock, even conglomerate for that matter, correct? Now, then you have chemical sedimentary rock. What are chemical sedimentary rocks? So those sedimentations which have happened due to, or those sedimentary rocks which have been created due to any kind of chemical reaction taking place. So here, let me tell you about the formation of iron ore deposits that you find on the surface. Now, iron ore, limestone, they are examples of your sedimentary rocks and chemical sedimentary rocks. Even though nobody is going to ask you in UPSC that how these rocks have been created, but you should be aware of that. So here when we talk about it, let's suppose understand how iron ore was created. Then I will tell you very briefly how limestone also came into existence. So the shallow seas and the oceans, that is a water body, at one point of time when they were newly created, right? They had the presence of dissolved iron. Dissolved iron. Now, over a period of time, plants, they came into existence. Plants came into existence here. Now, these plants, they would carry out photosynthesis, isn't it? So, they would consume CO2 and they would end up producing oxygen. Now, this oxygen would combine with the dissolved iron. So, you had a reaction Fe plus O2 would give Fe2O3, which would be solid. Oxygen would be in gaseous state, iron would be in dissolved state, but Fe plus O2 would give you Fe2O3. So this will be right. So here, that is how you had the creation of iron deposits. All these deposits, they started settling down at the bottom. All these solid deposits, they started settling down at the bottom. And that is how you had the creation of iron ore reserves. And the iron ore most of them that you observe in many of the areas. Now, what about limestone? Now, limestone is also something which has been created underwater. So that means wherever you come across a deposit of limestone, that means that region would have remained underwater at some point of time in the geological history of that region. So how is it that limestone gets created? So limestone is generally created in shallow seas where the seawater is not very deep, right? So in those regions of shallow seas, you have various shell bearing animals, crustaceans, mollusks. For example, you have the crabs, the lobsters, all of those which have a shell around them. Now, when these animals die, their shells they get deposited. The shells are generally rich in calcium carbonate. Now, over a period of time, these shells they get compressed and they turn into a rock-like structure. And that is what you have as limestone. That is why limestone is so very rich in calcium, right? Calcium carbonate is one of the abundant elements present in limestone. And that is the reason why, because calcium has got a binding property, that is why limestone is the most important raw material in the manufacturing of cement. Whenever you observe the manufacturing of cement, one of the important raw materials is limestone. And that is the reason. So this is basically the case of chemical sedimentary rocks, where these rocks have been created or the formation has been initiated due to a chemical reaction. Then you have organic sedimentary rock. For example, take the case of coal. Now, how is it that coal is formed? Coal is formed when you have the trees, they die. Now, they get deposited on top of one another, and then they are further, they are enclosed by the deposits of other sediments, etc., and they are compressed over a period of millions of years. That is how coal is formed. So that is an organic sedimentary rock. So depends upon or depending upon how that sedimentation has taken place, how that sedimentation has happened, you have the varying category of sedimentary rocks. Okay, right? Now, Mishra, I hope that you understand now. Now, after this, there's a question about the characteristic of the primary rocks and its types. Sindhu, that is what, okay. First of all, let me ask a very simple and a frank question because I have seen two of you ask the same thing. How many of you are sitting there in the session with a previous year question opened in front of you? It is not bad. Okay, I'm just inquiring because one of you had asked about the Juno mission. One of you are asking about the case of primary rock systems that we have already talked about. See, you have to understand when we talk about the primary rock, that is your igneous rock. Now, I have given you the simple type of what do you understand by igneous rock, how it is formed, a simple classification. When we talk about the chemical characteristics of magma, there we will also be talking about the mafic, ultramafic, felsic. So those magmatic materials, they will solidify into ultramafic, mafic, and felsic rocks as well. Okay, so it is a simple expression of those particular details that you need to be providing in that answer. Okay, is that clear? Who had asked the question? Sindhu. Is that clear, Sindhu, or is there any other doubt that prevails? Are all limestones are sedimentary? Yes, Anurag, they are sedimentary. They are found in the Himalayas as well. Yes, correct. Okay. So when we are talking about the primary rocks, that is where you have to understand many of the coaching institutes till today, they will tell you that the primary rocks also include of sedimentary and metamorphic, but it is not the case. Primary rocks are only your basic igneous rocks. So the question that UPSC asked was that what do you understand by primary rocks? Discuss its types. Now, there you have to first of all elaborate upon what the basic question, what do you understand by primary rock? So, how they are created? So, they are created by the solidification of molten materials. Now, then you have to elaborate with the help of the image that the solidification can happen either on the surface or in the interior. When it happens on the surface, what happens to the crystal size? When it happens in the interior, what happens to the crystal size? Along with examples, you have to elaborate this basic. Then after that, even these rocks are classified into felsic, mafic, ultramafic, depending upon the predominance of materials such as iron and magnesium. That is something we will cover when we talk about the chemical composition of magma, which we experience during a volcanic eruption. So you will get a better idea as well. Okay. Petroleum, how petroleum is formed. So petroleum is again created as a result of marine deposit. Petroleum also, wherever it is formed, that place would have been underwater, because petroleum is formed by the fossilization of the marine animals, right? While coal is formed due to the fossilization of the forest, the trees. The trees, they die, they get deposited on top of each other. On top of them, further amount of deposits happen. It gets compressed over a period of millions of years, and carbonification process leads to the formation of coal. We will study about this more in detail about coal in the portion of minerals and industries. But when you talk about petroleum, petroleum is created underwater when the marine animals, they get fossilized, and then there is another deposit on top of them, so that a complete decomposition doesn't take place. So that is those marine animals and their fossils, they end up creating crude oil, petroleum and gases. Okay. Petroleum is not a sedimentary rock. It is a kind of a deposit, right? Okay. Now coming to the metamorphic rocks. Now, metamorphic rocks, observe the image again. In every topic, first of all, I want you to be observing the image. So observe the image here. You will observe that the structure is significantly different as compared to the earlier ones. And this happens when you have the existing rock type experiencing high temperature or pressure, and that pressure can be exerted either in the interior of the planet or can be experienced due to the compression of the crust. In either of the cases, that rock changes its nature, its characteristic. Sometimes it will appear in a banded, layered like structure, which is referred to as a foliated metamorphic rock, and sometimes it will appear very uniform like an igneous rock, which is non-foliated, right? So that is your metamorphic rock. So foliated metamorphic rocks, these are produced whenever you have a kind of a layered structure. So phyllite, gneiss. Gneiss is formed by the metamorphosis of, generally, which kind of rock leads to creation of gneiss? It is basically which one? Let me know. Granite in general. Okay? Yes, correct, Garvit. Granite ends up creating gneiss. Then you have non-foliated marble, quartzite. These are examples of non-foliated. They won't give you that appearance of layered structure. Okay? Now, Kavya, difference between metamorphic and intrusive. Igneous. Metamorphic, an existent rock type gets converted into metamorphic. Intrusive is, or igneous rock is directly formed by solidification, right? Intrusive igneous rock over a period of time can get converted into metamorphic rock. Okay. Now, finally, the final topic of the day that we will cover is the rock cycle. So basically, what does the rock cycle tell us? It tells us that no rock is permanent in nature. Any rock type, when they are exposed to different conditions or a suitable conditional requirement, they can change their type. For example, a metamorphic rock, let us consider a metamorphic rock. Now, this metamorphic rock, when it is exposed to weathering, erosion, or breakage, etc., it can get converted into sediments. Those sediments, over a period of time, can get deposited, compacted, cemented, can lead to the formation of sedimentary rock. That sedimentary rock can again get broken. into various parts, smaller parts, and again, they can basically resolidify. In the other way, that sedimentary rock, let's suppose, is present in a region where there's a lot of crustal compression. The crust is experiencing a compression like you observe in the case of the Himalayas. So, in that case, that sedimentary rock can get converted into metamorphic rock, isn't it? Now, let's suppose due to the movement of the rocks, the movement is such that one portion of the crust undergoes or goes underneath the other portion. Now, there it will melt as it goes underneath the other portion of the crust at a depth. Due to high temperature, it will melt, it will form magma. So that magma, it can cool down in the interior itself, forming an intrusive igneous rock, or it can come out as lava, right? So molten materials, by the way, when they are present in the interior, they are referred to as magma. And when the same molten materials, they come and emerge on the surface, they are referred to as lava. So that molten or that metamorphic rock can get converted into magma due to melting. That magma cooling will lead to formation of igneous rock. That igneous rock can again undergo the same process, or it can break into a sedimentary rock, or break into sediments, lead to formation of a sedimentary rock, or that igneous rock under high amount of compression or heat can change into metamorphic rock. So what this tells you is that any rock type, when it is exposed to different conditions, it can always change from one type to another. That is what is rock cycle. Okay? Is it clear up till now? Metamorphic rocks, Deep Shikha, is basically those rocks which, over a period of time, when let's say an igneous or a sedimentary rock, when they undergo a lot of compression. For example, take the case of Himalayas. Now, when Himalayas were formed, we will talk in detail about that as well tomorrow. So, when the Himalayas were formed, the crust got compressed. So, if there was sedimentary rock here, if that is getting compressed significantly in this portion, the existing sedimentary rock, they will experience high amount of pressure, high amount of heat, so they change their structure into metamorphic rock. Okay, do we need to learn it thoroughly? Absolutely not. None of these things or none of the topics that I will cover, none of them need to be learned thoroughly. They need to be understood. What you understand, you don't forget. What you learn, you immediately forget. So please don't by heart it. Try to understand it. Okay. Which is more harder, igneous or metamorphic? Generally, igneous. Generally. Shale formation, again, shale is again formed in the sedimentary beds. Shale rock, the Javaria, you will find in the sedimentary beds. So be it the shale formation in the KG basin, be it the shale formation in the Shekhawati region of uh, Rajasthan, or be it the shale formation in the Cambe basin. In all those areas, they have also been created due to fossilization itself. Okay. Akshita, it is the igneous one. Okay. Rock foliated basin. What is foliation? So when you observe an onion, for example, all of you would have seen an onion, you would have cut an onion, you would have observed that onion gives you various different layers. So sometimes the rocks, they give you that banded and layered structure or appearance. That is what is foliated and non-foliated. Okay, is that understood? In Saudi, there the oil comes from under the earth. No, everywhere the oil which is extracted, mostly it comes from under the earth itself. So wherever you find that oil deposit today, be it in Saudi, be it in Kuwait, be it in India, wherever you find the oil deposits, that has been found or that has been formed when that place was underwater. So all those places, they exhibit that they have been underwater for some point of or the other, right? For example, Rajasthan is again very rich in, or there have been greater explorations of oil there, right? They are extracted from underground. How is it that oil has been formed there? When Rajasthan was underwater. Okay. Right. So that is where we'll end the session here today. And I hope that the session has been understood. Overall, I hope that basically you are making some headway in terms of grasping the topic. We have still not scratched very deep into it. We have still covered very much significant portion of it from a story point of view. So we will be sinking our teeth deeper into the portion of geomorphology in the coming days as well. But I hope that overall you are able to understand this. Yes, all of this is a part of physical geography. Physical geography will continue for the initial 10 to 15 days, or 15 to 16 days, 2 to 3 weeks. We will be covering physical geography. I'm sure by the end of it, many of you will have that kind of a grievance that why are we paying so much attention on physical geography? Because this is the concept laying part. Once you understand these concepts, the concepts that we studied today, those concepts will be again recalled when I tell you the story about the formation of India itself, that how the entire country was created in bits and pieces and different parts. Why is it that you have certain areas having a greater depth of water? Why certain areas don't have that? Why is it that Chota Nagpur Plateau is referred to as the oldest landmass across the planet Earth? Why is it that the Aravallis are referred to as the oldest mountains of the planet? So these factors, when we talk about, so all the concepts that we have studied till now, it will be applicable at that point of time. Okay, so as of now, I just want you to be very comfortable. Okay, any issue that you face, please raise it up. Okay, don't hesitate. Where we find maximum volcanic eruption, in certain areas where the we will study tomorrow about plate tectonics, hopefully so you'll get an idea. Okay, and how to study after the session is over. Manish, as of now, just do the basic, revise the portion of the PPT, annotations of the PPT, the additional reading materials which are being provided to you, revise it with that as well. If you have enough time, look at the module that we are going to cover tomorrow as well, in cases that it is available to you. Okay. Where we find sedimentary rock? Everywhere. Any place that you go, you'll find some or the other sedimentary rock. Whichever portion of the country you belong from, you will find some or the other sedimentary rock. Somo, can I use the book? Yes, absolutely, yes. And Gauri, that is good to know. I hope that the interest continues when we come into the crunch areas like climatology. See, the problem here which arises is that the candidates, when they find a topic tough, they quit the entire subject, and that is the worst thing that they can do. So rather than having a tough topic which you are not confident of, you end up having a tough subject that you have no clue about. And UPSC will not give you marks that how many times you have studied the easy subject. UPSC will ask you 15 questions from geography 1 and 5 marks from geography. So that is where you need proficiency, you need some perseverance. Stick on to this particular concept and the approach, and we will be in a good place. And good. Garvit, can we